Yesterday we were able to conclude by looking at the propagation delay time. And this was basically the time when an effect in the input will produce an effect in the output. So input change causing a change in the output. And we concluded that the time when it changes from, when we have a change from high to low, is never equal to the time when we change from low to high. And so that concluded our part of digital. We are still under digital circuits, but that bit of introduction of the digital circuits ended there. And we had looked at a binary logic device. We tried out a binary device as an example, being a manual switch. And this manual switch gave us either an off or an on. And these were clear or distinct or definite states which you can switch between. You can either flip off or flip on. And the best example of this all stuff, the best things to make us understand are the basic logic. This is our experiment D1, D2. We shall, the same principles in D14, the D14 will come out. So I was always explaining the D1 and D1 because the way I was drafted the experiments, D1 D2 would always follow D1. So whenever I would explain, much as I used to take more time about D1, the same group will be doing D2, so it has been helping me. I'm gonna do it now, but just relaxing in the lab all the time. So what is a gate? All of you have ever entered the gates, isn't it? Yes. Some of you got them at home. We didn't have a gate. Maybe we had. But I don't think we had. We just had this live fence and with the name a hole, not a hole, a place where you were. We didn't have anything. I mean, in the village we don't steal. It's not like here. Here when you leave your thing on the veranda, it's like it is a crime to leave things outside on your veranda. When you buy a vehicle, immediately you get out of the bond, it is scrapped because they leave it everything, everywhere. Lights, even small thing that can be removed, you leave it. You know, leave it. Something they put to tighten it. So the moment a car which was driven for over 10 years in Japan becomes scrap when you buy it from the board because of stupid thieves. When I say stupid thieves, everyone goes to offended? Why did you have to keep quiet? Let me first think. So a gate. In this sense, a gate in this sense is that we can have one or more than one inputs and then only one output in this case. And then these inputs must be present. So when we say present, you are doing it there and then. these gates we are started with, or we are looking at, they do not keep, they are not, you know, these people, which people in Uganda keep grudges. Like they say it's okay, then like you now, you kept the grudge. I missed you, I apologized, I forgot, now you're saying, but you remember the other time. So, there are systems, there are gadgets, there are devices which keep grudges. Now when you are trying to put in another state, it says, but I am already on. You are saying on again. So it reminds you, that is like keeping grudges. These gates do not keep grudges. They depend on there are these people, especially maybe Paul doesn't understand it. The drunk people, the people who go to the bar, they are this type. What you discuss in a bar ends there. If you meet tomorrow, you say, you promised me a job when we were at the other bar. He says, I don't remember. And I have a story which I'll tell you probably in the future of why I also left booze. And yesterday I told you that was a climax. But when I was here, we hosted some young man. He was either a friend or he was an acquaintance of my roommate. In my room, when I went to Susan's place, I met there, that place where I was. I met there a relative, I think a brother to the wife of my uncle, and he was working in a factory. So they gave me, I think, a kilo of tea leaves. You know how much a kilo of tea leaves is? Tea leaves. That will take, imagine if you are reach a kilo. So I came with a big camera of tea leaves. Because he was in the tea factory, so he just scooped before packaging, he just put in a big camera. And then I also had someone who had given me sugar, too much. So my room was like, whoever came, we had this coil here, which does like this. I think it has a handle with wires. So you just put in a jug and instantly make it. So this guy appreciated our room, allowed me to use a minute or two. When he appreciated our room service, even in the dining, I would take him there and tell the chief cook, whatever they called him by then, may he so rest in peace, and he would be served with chicken or whatever, caras of me, because I was friendly. So one day I'm coming from the library, after reading, I'm just remembering some shops. He said, "Oh, Ben." I said, "Yes." He said, "By the way, I'm glad you have hosted," because he was chasing his transport. He said, "I want to buy you beer." It was around May, time when Champions League is at climax, and some guys were watching the Champions League in the Sivirwa senior common room. There was a canteen outside there. So I told him, I can't drink when we are having exams soon. We are in tests. But you can buy me an Ofono. Ofono. Oh, sorry, Ofono. Ofono was 500, I think it was 700 or 500 glass bottle of Coca-Cola, bigger. So I was like, you can buy me the Ofono. Ofono was not there. So I said, but Bell was at 1K. Since Bell is at 1K, you can let me get 2 small Coca-Cola. He said, if you don't want to drink beer and there's no Ofono, let's leave it. In that way, with like as if he's annoyed. It puzzled me. You are always giving me an option. You are now chopping off your wires. I am not your brother. I did not beg you anything. Those are my thoughts. So every time I have traveled, I make sure I inquire from Chinese, inquired from Italians, I inquired from Ghanaians, from Kenyans. I said, why is it that someone can make me drink 1 million in a bar, but cannot give me 1,000 shillings? They say, that's how it is. Come drink my money, don't take nothing home. So I said, you can go drink your stupid beer in the bar, I'll never be part of that nonsense. At home, people are dying, then I'm here enjoying with you in a bar. When I say, at least give me for 1 kilo to take my children, you say, no, no, no. Those are your problems. Yeah, you drink your beer. So that's another way. That came before, but the other problem of the basin under whatever came when I was now trying to forget the other issue. And now I sealed it. No more intoxication. Gates do not hold grudges. They are like one tribe in Uganda. If you annoy him, he boxes you, and then it stops there. Tomorrow you are friends. He doesn't even remember that he boxed you. If you remember, that is your problem. But for him, he sees it there. So yeah, those are examples of gates. So gates are, or a gate is its most basic digital device. Most basic digital device. It has more. It has more. Sorry. It has one or more inputs. Soon or later we shall do Boolean algebra. Tell me the other name of Boolean. Right? Yes. George. So he has his 20K next time. But did he Google? Yeah, you had read somewhere. So now.
It was instant.
Huh? It was instant. So you have 20K. If you use MM, after here I can, let me see, yeah, I got a man on MM, I can transfer the money to you. Since you know my names, I will not get scared that if you use MM, after here I'll give you a 20K instantly. Since you know. So that you enjoy your cassava. So it has one or more inputs. And a single, why are people feeling bad for him? But yeah, I put the thing on the table and he went for it. There are no penalties. Whether you get and fail, no penalties. That's how people get rich. So it has one or more inputs and a single output. And a single output that is a function, this output, it is a function of the current inputs only. So a gate, not the one at home, but an electronic gate, is one of the most basic digital devices that can give you a 0 or a 1, an on or an off, a light on the LED or a LED which is off, easily. But it all depends. It can have more than one, and it has a single output, and this single output depends on the current or present. There is no stored state that you will find, for a gate. The most important gates that we are going to meet, the most important gates, we have an AND, we have an OR, and we have a NOT. I'm yearning for a time when we shall evolve, that I will just come here and talk and explain what can come in my mind, and then you go and make your notes or go follow your notes. The reason I can't do that, when something goes wrong, some of you will say, after all you would come and talk. That's why things became a problem for me, even if it is one or two. They get an excuse. So that's why I chop everything. There is no student who can ever come and say the guy never used to attend, or he just never used to come and talk whatever he wishes or explain without giving notes. I give notes. Some refuse to take it, but like Monga always wants to go to PC. Now I'm keeping. By the way, did I bring you in front at one time? He's laughing. Okay, so the reason I'm saying that is that it would have helped me to go through the basics of these gates, and we get to understand it. If you would compensate the time in your free time and go through the notes and get the basics. But some people say, you didn't do the work. Like I told again, like I normally tell you that I cannot sing along with an artist on a concert when I have paid money. So some of you say, we paid fees, or government is paying our fees. Let him hustle. One time I said, can I just go on the train? You write, it is okay. So I will do that. But so for D1, for those of you who are going to be, who are going to done D1, hence going forward, so that when I'm rushing through next time, it becomes easy for me. We have two scenarios. We can use a diode logic, and when we use diode logic, we can make either an AND gate or an OR gate. And the note I'll also explain, so that, because today are practical, so let me do this to help myself. So if we arrange the diodes in this form, two diodes, we have D1, and then we have diode D2, and they are in this form. And then we have the inputs we are talking about, and then we together we tap here an output. So if this is X, and this is Y, and then we have Z as output. I'm following the nomenclature in the book. We can get an output here, and I'm going to, for this case, we can have a supply of 5 volts, the VS. So we have the 5 volts here, the VS. And then for purposes of getting to see what is going on, we can connect a protected, this resistor here is for protecting the LED, a light emitting diode. And then we ground it to complete the circuit. So the idea is that when you connect this like this, and this one is not connected anywhere, then this current from the 5 volts can never flow here because the wires are hanging. And because this one is terminal to the ground, there is now a complete circuit. When we say ground, it's like we have completed the, if this 5 volts was coming from, for example, like this, then this is what we mean. The circuit will have looked like this. And on the breadboard, we just have the terminals where we get the ground. We have the ground somewhere, we have the 5 volts somewhere. Most of them are dead. Then we have a potentiometer, one with a potentiometer for plus 15, and the potentiometer will be able to give us an adjustment to get us that, and then minus 15 volts, another one, another terminal. So there are 4 terminals for the 2 big breadboards. There are also breadboards which do not have anything to do with the power supply. You fetch somewhere, but these ones got them. You plug them in the mains, then they give you the values that you want to change. For the dots, the dots on the breadboard have 2 lines, the dots, mostly red and the blue, and then dots. The dots on these 2 lines are continuous along this, and then we have some other dots, I think A, B, C, D, E, is also F. And so these many ones are continuous along here, and they are discontinuous along here. And then there are compartments. The ones which we are using, the 2 breadboards, are 6 compartments. If you go into another level of blue and red, you must make sure that you get a wire and put there. The reason for these holes is you are able to tie together the components without tying them actually. So that once you have done it, and then you can transfer to the PCB, the printable circuit board, which you now, so if you have been tying your legs of the diode, now when you want to solder them, they are all crooked, so they are spoiled. Here you just have to straighten up the wire and push in the hole nicely. If you push in the hole nicely, it can take a good length, but you don't need it to be too long. As long as it fits there, it connects to the wire. So there are this gate here, now that we are on gates, I can say it here so that I finish it at once. This gate has, so the connection, I hope now you understand why I say that this is terminated to the ground. The ground is this negative for this. We are not using dry cells that we have to strictly continue and have the negative side. Once you have the negative, the grounding of one probe, for example, of an oscilloscope, if you are using the other probe somewhere, it is automatically grounded in a sense because it is already having that part. Once you put on the positive part, the output part, the other one, even if you don't ground, especially like for experiment E1. Once you have grounded the output, the input part, you will not have to put at CT, the center part. So I ground to complete the circuit, and then there is what we call a truth table. All possible options, because that's the next thing I was, truth table of a gate. Maybe we first write that, then I complete that so that you know what. So those are the most important gates. Then we look at the truth table of a gate. I would love, if God gives me my wish, that in the future I can come with all the stuff here, especially like in a course outline, so that I show you everything from here. I don't know. So the truth table is a list. This is a list. This is a list of possible combinations. Possible combinations input logic variables, logic variables, and corresponding output logic function variables. Logic function. We say variables or values. You could have said the logic variables. Are they variables now or values? Whatever. When I say whatever, I don't go around and say the man just said whatever, he says whatever. And so a logic variable, we have either a 0 or a 1. And the logic function is, I think it is function values. It's either also either 0 or 1. So we shall do the add on a few things after I have explained here, so that we are all moving at the same pace. So truth table is a list of possible combinations. So the possible combinations are that I have x variable, y variable, and then I have an output which is a logic function of these two. And so the possible combinations are that I can have mathematically 0, 0, 0, 1, 1, 0, and 1, 1. But electronics-wise, this is ground, 5 volts, 5 volts ground, and then 5 volts, 5 volts. So before I connect anything, when I have these wires hanging in the holes next to the leads of the diodes, and then I also have, and this one is connected. The moment I have this 5 volts switched on the breadboard, current will not go through here because there is no path. It's like a road without where it is going. Like contractors are still working on it, and then they have stopped somewhere. Even if it is well graded, you reach there, you go nowhere. So you don't take the path. There's nothing. So, but then there is this path. Because of this ground, everyone, you see, ground is like a resting place. Everyone who gets tired wants to rest. Everyone who hasn't even done anything during the day wants to go and sleep. That's like the ground. This is, it even sounds like the ground the Bakara talk about. Have you ever heard of that? When you are sleeping on a mat, you are not worried. When you are turning, you turn comfortably. Even because you are not going to fall. But when you are on the bed, you first feel whether you are okay. Because of the mechanics, you study that reference point. The moment you have a couple of distance from the reference point, your potential energy increases. The MGH. As long as you attain H, then now you start being insecure. If I am right now, if I try to climb on this table, much as it has to do whatever, but I'll be careful. I'll be starting to see that I'm not on the edge. And this is just a short distance out of the ground. But I would already have gotten the potential energy. What do you mean? So this will light on the breadboard when you switch on, because the current is busy flowing this side. Now, let me first do the deeds. So we have a scenario where we ground. When we ground and ground here, we have gotten a way of where the current flows. Current will never struggle to go through this resistor here when there is free wheel this side, because this flow is in the direction of the conduction of the diodes. So this one will leave this place having nothing to show. When you ground here and put 5 here, then remember when you put 5 here, 5 cannot go through, but it will remain there. It's like every night an askari is inside the gate with his gun. He doesn't care what is outside until when people come and they want to enter. That's when he acts. He can't go out. It's just at the gate. But then, here where you have grounded, it becomes an easy, it's a hole. It's a loophole. You reverse. You put 5 here, you ground here. Comes in. It is only when, listen to the key word, it is only when you put 5 here and here, that then the 5s come here and block the 5 that would have opted here, and gradually it passes here, and then you get the lead light. And that's where we get the word and get. And this is where this most important get comes in. Yes?
The transferring of the pattern of the
Ground is that we put this one to meet here. We put this one also. The two of them now are connected here. And when you do that, then this one quickly, because it would have taken a short, what you may think is a shortcut, but there is a resistor. If, I'm sorry, I will use the boys probably. If you wanted to go dancing, and then there is that corridor path, or there is that small path which passes where your parents or your elder brothers sleep. You don't risk, you can't take a risk to pass there. What if you were tiptoeing and something makes noise? You pass far away, where there is free will. So anything I am using far away, but here there is a resistor along the path. Here there is nothing, because as long as you are in the forward bias of the diode, you go through without any problem. You go without any problem. So that's the ground. You ground, you put a path that bypasses this, and then nothing goes through there, so your diode does not light. On this demonstration in the lab, when I switch off after it has been lighting, it takes long to go off. And in the lab it helps me, maybe that's what I'll be demonstrating. It helps me to show you that the electrons that had moved tiptoed to go and do conduction, and that process they made light to shine. When you switch off, they don't jump quickly like that. So they first again go back into their balances, and the light still goes out slowly. Once they have felt comfortable in their places, then the whole LED now goes on. That's what I was explaining last time when we were on semi. And recombination and diffusion and all that kind of stuff. So this is why we call it AND gate, and we are going to draw it soon. We shall draw it, which is just a line, a semicircle, 2 inputs. They could be more, but the best one will be having 2 inputs. And now this will be our X, this will be our Y, and this will be our Z. On the other hand, if I could borrow this part so that we see a comparison of the two, we could implement an OR gate, and by facing this direction. So we have the diode 1, we have the diode 2, I remember doing this in Kosovo, but you were always, he's joking, let him teach the damn things. We shall understand. So here we don't have any reason to put the 5 volts. But we put at our, here where they join each other, we have our output at the Z. The Z was here, or for purposes of having it make more sense. And then we shall have the resistor. In the book, in the manual, there is an 100 ohms resistor for acting as this. But because you may fault in putting this 100, we want to be safe. So we have this 1K, I think it is about 1K to protect our legs, so that you don't blow all of them at once. So we go to the possible combinations of input logic values and look at corresponding logic function values. So, and we do that in form of a truth table. I don't know whether there is a lies table. I don't know why. You can steal from me, but I hate being told a lie. It's just, if you lie to me, you never recover the trust. So these are the possible combinations: ground, 5 volts, 5 volts, ground, 5. Because we are using, when there is 5, it is on, which we give as 1. So if we ground, got nothing in our circuit. So we got nothing on there, LED. There is this and then a light to emit. So we got. If we put here, if we ground here and put 5 here, 5 will and then come here and give us the light. If we put 5 here and ground here, 5 will say, you are joking. It goes. Remember, some of you will say, but when the 5 comes here, why can't it go here and go to ground? It is blocked because this is reverse bias. Then it comes here, it lights. If we put 5 here and 5 here, they both flow, they combine, and this is the reason we put this resistor to make sure that the lady says, you are fake, you must struggle there, don't come on to me, because it would have been 10 volts. That's why on one leg of on the positive leg of the LED, we soldered there a resistor. So when you see it there, don't start breaking it off. The reason it is soldered there is to protect the light emitting diode. So whether you put here, so when you put 5, 5, they all flow here, we get 1. So you can either, to get light here, you can either have a 5 here, a 5 here, or a 5 on both of them. That's where the word "or" as a gate came by. So, and it's like a fish head with 2 inputs and 1 single output. They could be 3, they could be 4. Now, I want you to understand what gets, and if you go to Nericon and read that part of the theory in Nericon, the 7th edition, they will tell you a gate, what we are looking at as a gate is like the possible scenarios if I enter this one. If the output was for me to teach you so that you are able to see, like if it was an evening lecture, there are many possibilities. I can come in and find when the light is on and when you are also around. So if I come in, there is light and you are here, then I will be able to teach. If teaching was the output, then that is the scenario. If you were here and I have come and you are here, that is 1, but there is no light, which is 0, then we end up not being able to learn. So that is like the and. The light is on and you are also here, then I will be able to teach. So I don't want you to take gets as if they are very exotic things. They work with diodes. You can't work with what is it about. And that's why when I was here for course outline, I told you that the elevators, the lifts, use the Boolean algebra. You just come thinking also, you reach the buttons, you just press the one going up. After pressing, you wait a bit, it opens up. You enter. It's a keyboard, a keypad with a row of 1, 2, 3, whatever you say. I'm going to level 2. You just start looking, start looking at their teeth in the mirror, and then check whether there is anything in it. And then they wait, and then it opens when it reaches where you are going. No hassle. But it remembers, this one punched me here, this one punched me there, this one did this. So it can't even take shortcut that I've reached 2, let me first drop this one. It takes the one who, the current input. Remember, this current, I don't know where, I rubbed it somewhere. The current, which, if we enter, someone, the first one puts 7, another, there's one who enters second puts 1. It does not drop at 1. It goes to 7, drops the one who put. Comes to 1, drops you. So you have to be patient. See, but we have reached 1, you start, no. That's why they made it in such a way that you can't even know where you are. You just depend on it saying now. And then when it opens, you see it shows the flow which has been, which is being opened up for, and then you go out of the place. I want you to understand these things. That's why the key word is, this is the key word here. Some of you don't have logic actually. You just go around with, you don't put questions on why side. Someone does something and you are like, okay, no, me I put logic. When I was doing my master's, there was some old Nepali. He would just, you don't even know when he sloped to the campus. Then when he finds you in the lab, he said, let's go back home, let's go back. So one time I told him, you didn't call me when we were coming to campus. Now you are telling me to go back to that we go back. I came alone. You came alone, I came alone to this place. If you had called me from my room, because even phones were free, it was enough. Then I could say, yeah, we came together, we go together. So you have to put some logic, although some of you don't work very well with logic in one way or another. So for purposes of the people who are going to do D1, this is how the and or comes up. And then we have a map where we have chips, where we have the map and we have legs. Legs up to 7. 1, 2, 3, 4, 5, 6, 7. And then 8, 9, 10, 11, 12, 13, 14. And then we have these put inside. Before we use them, once we have put this on a breadboard, first thing we put the 5 volts at the 14th leg, and then we put this, we ground the 7 pin. That's when we will be able to use the contents inside. So in case it is NAND, for example, if it was a 7-4, NAND is what? AND is what? 7-4, 3, 2? Yes. If it is a 7432, that means that this leg here, so this will be, if this is AND, this will be our AND, like this, and then this one is the output. So this is 13, 12, 11. And then you would have the 1, 2, this 1, 2, would have a gate here, and then this is 1, 2, and 3 would be our output. So this is our X, this is our Y, this is our Z. So if you want to, work out, use any of them. For example, if you wanted to put the LED now would be here. So this would be our LED for the output, for purposes of getting the things. And then you will now put here X, you put 5 here, you will get a wire, you put at 5, get a wire 5, ground, you put at 5, then ground 5, then 5, 5. And then watch what the LED does. On every occasion you are doing that, make sure that you make it off. Otherwise, if you are so fast, ground, then it will keep writing. What the hell is going on? Because it does not go off instantly. So that's why you switch off the breadboard, you put your states, then you watch. So the next part about this is about drawing the symbols, both American and IESC, then the truth tables, there's a couple of them, and then extending things. So because the reason I'm doing this is because we meet in after a long time, because stars are not going to come. I could have, if the venue was different, I could have used the 30 minutes. But also a human being. I think let's have a break also. The one of, since you have brought the grudge, the one of that thing I will compensate it. So you look for time for me to compensate. And so I meet you at 2 for the Wednesday group, and then the rest of you, the Friday, we meet on Friday. Those who are doing D1 on Friday, now I will be just explaining the practical bit, the theory now you know. And then Tuesday, we come when we are charged up so that we cover almost these gates and finish them. And so that when we now go to the lab, we do meaningful stuff. And I think now you appreciate what I told you, that it's a hassle. We get this on practical. When we come to theory, we see it. We do it in the theory. If we are lucky that we do it in theory, and then we do a practical. When we have done it in theory, we benefit. It's your damn country and your damn continent. Otherwise, I should be able to run a practical on every theory that we cover. Nevertheless, we are lucky we are alive. Isn't it? So you don't complain. Mine is a biological mistake or geographical mistake that I ended up in your Africa. See you at 2. I see you at 2, those who are doing the plan. What is annoying me is now I'm making the board to look very nice for maybe yesterday it was really bad.